Okay, let's talk about the general formula for the determinant. So far, we've learned a lot of different special matrix determinant. For example, the determinant of, okay, we call it a scalar matrix or just a one by one matrix, right? It's a no-brainer. The result is just A itself. Okay, we've also learned, for example, a 2 by 2 matrix. We've also learned its formula. Okay, it's going to be this AD minus BC, right? The diagonal minus another diagonal product. Okay, in problem 2, we've also learned, for example, the determinant of an upper triangular or lower triangular matrix is the product of the diagonal entries, right? Or if a matrix has all zero row or all zero column, its determinant is 0. Or if a matrix has two identical rows or identical columns, then its determinant must be 0. Okay, we've learned a lot of special cases determinant. So is there a general formula for any square matrix determinant? Okay, the answer is of course yes. Okay, for a general, let me talk about that. For a general n by n matrix, okay, you can choose any row or any column to calculate its determinant. Okay, you can pick any row. Okay, for example, let's pick the case row. Okay, you can pick any column. Okay, so you either pick one row or you pick one column, and it could be any row or any column. Okay, after you pick that row or column, you just need to get its cofactor matrix row. For example, if you pick the case row, then you just need to get the case row of the cofactor matrix as well. Right? Let's say if instead you didn't pick the case row, you picked the, let's say, okay, let's the third column, right? Let's say you pick the third column. Then you just need to get the third column of the cofactor matrix as well. Okay, then what you do, you dot product them. Okay, or let me write it down. So case row of A is AK1, AK2, all the way to AKN, right? That's all entries of case row. C, right? Cofactor matrix, it's the same. It's CK1, CK2, all the way to CKN. Okay, it's a case row of the cofactor matrix. Then the determinant of A, okay, we can write it in this way or we can write it in this way. Both are the same. It's going to be just AK1 times CK1, okay, plus AK2 times CK2, right, plus all the way to the AKN times CKN. So you just have to, right, dot product them essentially, right? Then that result, that sum is going to be the determinant. So it's the summation of AKI times CKI for I from 1 to n. Right. Okay. This is a general formula, okay, for any square matrix determinant. Okay. So let's do this problem. Let's do this problem. This problem, it's a 4 by 4 matrix determinant. So A is a 4 by 4 matrix. All right, so let's directly go to part B. Part A is not that necessary. Evaluate the determinant of A by cofactor expansion along the first column. Okay, so let's pick the first column and get the determinant. Right, so now I pick the first column. So the determinant of A is going to be what? So first, you need to get, you don't have to figure out the entire cofactor matrix. You just need to get the first column of the cofactor matrix, which is C11, C21, C31, C41. You just need to figure out these four, all right? And then it will be just A11 times C11, okay, plus A21 times C21, plus A31 times C31 plus A41 times C4. All right? You just need to get this. Okay, let's do it. A11 is 2, right? This entry. And what is C11? Okay, so C11, don't forget about C's formula. Cij is -1 to the power of I plus j times the determinant of A after you've deleted the ith row, and the jth column. Okay, so C11, you delete the first row and first column of A, you get the determinant of this. Okay, you get the determinant of this. Okay, see, the determinant of a 4x4 matrix, right, is composed of the determinant of 3x3 matrix, right, times a number and then sum them up. So it's like a recurring process. You have to keep doing the determinant. And A21, right, A21 is 1 times C21. C21 is the determinant of the matrix A after you've deleted the second row and the first column. Okay, so it's this matrix. It's 1, 3, 3, 2, 2, 0, 1, 2, 3. Right, plus A31. Okay, A31. Right, here is, we love it. We love it because A31 is 0. So C31, we don't even want to write it down because whatever it is times 0, the result must be 0. Okay, so here you can just write 0 here. Right, so you don't have to write the formula for C31 here. But if you want to write it down, you should. You can also write it down based on the same formula. Okay, plus A41. A41 is 0 times C41. Again, we love the 0 here because now we don't have to figure out what is C41. Okay, great. So that's the first thing about get the determinant of any matrix. We always love the line, so we always love the row or the column with a lot of zeros. Okay, that's a general principle. We love the row or column with lots of zeros because that could simplify our calculations a lot. So here's the trouble, 2 times, okay, now how do we get the determinant of this 3x3 matrix? So again, we have to apply the formula. Okay, now let's say instead first we can get the determinant choosing any row or any column, right? That is fine. But let's choose a row or column with most zeros. So for example, if I choose the first row to get the determinant, I have at least 1 0, right? It's better than no 0. So let's write it down. So it's this 0 times, right? Okay, let's give it a name. Okay, let's give it a name. Okay, let's do it here separately. Otherwise, it's a little bit confusing. So let's call this matrix B. It's this 3x3 matrix, and then you want to get its determinant. Okay. So, and let's say we expand the determinant by the first row, so it's going to be 0, right, times, right, it's B11 times B's cofactor matrix 11 entry. So what is B's cofactor matrix 11 entry? You delete the first row, you delete the first column of B, so it's -1 to the power of 1 plus 1 times, now you delete this row, delete this column, you get this, okay, times the determinant of 2, 0, 2, 3. Again, you don't even have to write this down here because you already know this is 0, so whatever this part is, the product must be 0. Okay, plus 1 times, 1 times B's cofactor matrix 1, 2 entry. So B's cofactor matrix 1, 2 entry is you delete the first row, you delete the second column. Okay, so it's -1 to the power of 1 plus 2 times these parts determinant. Okay, 2, 0, 1, 3. 2, 0, 1, 3. Okay, plus here, this entry, right, 1 times, okay, after you delete this row and this column times these parts determinant. Okay. So it's negative 1 to the power of 1 plus 3 times the determinant of 2, 2, 1, 2. Right, so this part, it's 0. Okay, this part, it is 1 times 1. Let's write it down. It's 1 times negative 1 times, okay, this part's determinant, right? It's a 2 by 2 matrix determinant. We can just use this diagonals product minus this diagonals product. So let's write it down. So 2 times 3 minus 0 times 1. Okay, plus this part is 1 times, okay, this result is 1, right, times this determinant is going to be 2 times 2 minus 1 times 2. Right, so this part is 0. This part is minus 6. Okay, and this part, it is plus 2. Okay, so this part is negative 4. So after all the calculations, we get this determinant. It is negative 4. Right, then plus 1 times this part's determinant. Okay, so let's do it down here. Okay, let's do it down here. So let's call this matrix D. It is 1, 3, 3, 2, 2, 0, 1, 2, 3. Okay. And again, the determinant of this matrix. So first, we need to pick a row or column. So let's just pick the second row because here I have a 0. Okay, I love zeros in the row. So it's going to be 2 times, right? You delete this first column, delete second row, you get this 3, 3, 2, 3. Right, so it's negative 1 to the power of, this entry is 2, 1 entry. Right? Negative 1 to the power of 2 plus 1 times the determinant of 3, 3, 2, 3. Okay, plus this number 2 times negative 1 to the power of, okay, this is again the 2, 2 entry, right? Negative 1 to the power of 2 plus 2 times, okay, you delete this row, delete this column, so it's 1, 3, 1, 3. Okay, then plus 0 times, okay, I don't care anymore. So 0 times anything is 0. Right. So let's do it. It's 2 times negative 1 times, here it's this diagonals product minus this diagonals product. So it's 3 times 3 minus 3 times 2. Okay, plus 2 times 1 times this diagonals product minus this diagonals product. Right, all this matrix has 2 identical rows, so you immediately know it's 0. Okay, so this part is 0, this part is negative 2 times 3, so it's negative 6. Okay, so here, right, okay, all right, here I made a very serious mistake. Okay, I forgot to put, right, I only write half the formula for Cij. So C11, it's not only this part, see, you have to make sure you've also written down this part. It's negative 1 to the power of I plus j, right? Don't forget about that part. Never forget about that part. Okay, never forget about that part. It's negative 1 to the power of 2 plus 1. Okay. Okay, so here we have the result is negative 6. Let's put it up here. right? 1 times this part is -1 times -6. Okay, here it's 2 times 1 times -4. So let's just put it there. Okay, then plus 0 plus 0. So after that, it's -8 plus 6. Okay, so the answer is -2. Okay, very, very long calculation. Right, the rest of the question you can practice on. Okay, it's very similar. All right, for example, in part A, you just need to get different entries of C, and part B, part 2, along the third row. So now instead of picking the first column, you just pick the third row. It's a very similar process. Okay, you can try them as a practice. So again, a quick summary of problem 3. This is about the general formula of the determinant. It applies for all sides of square matrix. Okay, before, if it's a 1 by 1 matrix or a 2 by 2 matrix, we have some special formula, but this formula doesn't apply for 3 by 3 matrix or 4 by 4 matrix or higher dimensional matrix. Okay, for any n by n matrix, the formula that is always true is this. Okay, practice it.